Alright, today we're going to be talking about the integral e to the x sine x. I'm sure many of you guys have tried this. You've tried to use integration by parts and you've ended up stuck in a loop. There's a trick to get us out of this loop, but first I'll show you how we end up at this loop. When we see two functions multiplied together, we probably want to use integration by parts to solve for it. So the formula for integration by parts is that the integral of u dv is equal to uv minus the integral of v du. In this function here, we're going to set u equal to sine x, and we're going to set dv equal to e to the x. When we integrate this function down here, we're going to get v is equal to e to the x, because e to the x doesn't change when you take the derivative of it. Now, if we take the derivative of u, we get that du is equal to cos of x. And so we can now plug this into our original formula. We get the integral of e to the x sine x is equal to u times v is sine x e to the x minus the integral of v du, e to the x cos x. Now, it doesn't seem like we've made a lot of progress, but this is a different function, so we're going to try again. We're going to use integration by parts again. We're going to say u is equal to cos of x. dv is again e to the x, so that gives us v is e to the x, and when we take the derivative of cos x, we get that du is negative sine x. So now let's try plugging this back in. So this whole expression is equal to sine x e to the x minus, now we're going to use integration by parts, cos of x e to the x minus the integral of v du. So e to the x, and now we would be multiplying by negative sine x, but we're going to take the negative out. So we're left with plus e to the x sine x. Now this is a bit of a problem because we're now back exactly where we started. We just have the integral of e to the x sine x, which is what we were trying to solve for initially. And you could keep trying again and again using integration by parts, but you're just going to go in this loop again and again. So how do we fix this? The trick is in saying that I is equal to e to the x, the integral of e to the x sine x. So the final solution that we're looking for, we're going to call I. So now if we plug this into our original equation, what we get is that I, which is the integral of e to the x sine x, I is equal to sine x e to the x, which we got from here, minus cos of x e to the x, and we're going to carry this negative through, minus the integral of e to the x sine x. But remember, we called that I. So now what we can do is we can move this I over to the other side. So what we really get is 2I is equal to sine x e to the x minus cos x e to the x. And I is just our final answer, so we're trying to isolate for I. So if we divide by 2 and factor out an e to the x, we get that I is equal to e to the x divided by 2 times sine x minus cos x. And then you can't forget plus c. And if we want to do our last step here, we can replace I with what it originally was. So the integral of e to the x sine x is equal to e to the x divided by 2 times sine x minus cos x plus c. So that's how we get out of this loop, and that's how you get into it in the first place.